Hello students, welcome to the Turito School Foundation program. Today we would like to discuss about that very important class that is going to be for second. Yeah, we would like to discuss about that conversion of units. Already in the first part what we have discussed. We have discussed about that units and the system of units. Now you would like to go for that microscopic phenomena. In order to represent the magnitude of the microscopic parameters, you need to take that conversion of units and also multiples and submultiples. Okay, so that's what a special units and its conversion. For the macroscopic parameters, you need to represent the units. For the microscopic phenomenon, you have to consider the special units. Very simple. Its magnitude is going to be very small. So we would like to go for that special units. Yes, you have to get this one. Special units of the physical quantities and conversion for the 7th class students. We would like to go for that 7th class students. In their understanding level, we will go for special units and its conversion of units. Right? It's very clear. Yeah, you would like to go for that. Yeah, a physical quantity. Just you will go for this one. What do you mean by physical quantity? The measurable quantity which is known as physical quantity. It's very clear. If you are going to get that measurement of that mass, it is a physical quantity, but it is independent quantity. You have to know that this is a fundamental quantity, which is not at all derived quantity. So all the measurable quantities are physical quantities, no doubt at all. Some of them are derived, some of them are going to be fundamental. So independent quantities, dependent quantities, we have to take that. By the virtue of its state, there exists a mass. It is going to be independent. So it's very clear. So the physical quantities, that is very clear, you can confirm. Yeah, measurable quantities. They are known as physical quantities. Let's see if you are going to get that. Yeah, you have to identify this one. Oh, this is very clear. You would like to go for this. Yeah. Due to virtue of its state, you can measure its volume. Yeah, you have to get this. This is a three-dimensional body. It's going to be 3D. Yeah, we would like to go for that volume. Yeah, just if you are going to get that length, breadth, height, you have to get this one. This is very clear. You would like to go for this one. You for length, this is 1D, 2D. Now you can extend that. It's very easy for you. Yeah, you have to take, this is a 2D, this is also one 2-dimensional space. Just we have to take this one. This is very clear. We would like to go for this one. This is a 3-dimensional body. We are going to span that 2D to 3D. Especially we are considering the volume. You need to find out that volume of the one object, or you need to find out the density of that matter. If you are going to take that density, while you are talking about that number of atoms per unit volume, and you need to consider that mass of that atom. Its atomic mass is also going to be considered, its volume, and all these things are going to be considered. Yes, how you will confirm it is going to be having that high density, low density. You have to calculate that mass and its occupied volume. Yeah, you have taken that for 1 unit cell. Right, you can easily find out that volume is going to be length into breadth into height. In case of cube, L is equal to B is equal to H. So it's going to be L cube. It's very clear. We can easily find out that. Let's have the look into that matter. If you want to measure that, here you can take that force per unit area. You are going to get that pressure that is equal to force per unit area. Yeah, you have to get that. While you are going to take that, due to the presence of atmosphere, so if we have taken that reference, so you have been confirmed that mercury, which is going to be filled with that, due to the pressure, just that is going to be atmospheric pressure. We would like to get that rise of that mercury level fall, sudden fall, due to the change of that atmospheric pressure. It was related to the temperature. So you can confirm that. It's very clear. If you want to get that measurement of the pressure, you need to know about that force acting on that area, which is going to be acting on this area. It's very clear. We would like to go for that. So you will get that atmospheric pressure and its measurement. Yeah, it's going to be either in terms of centimeter or in terms of meter. Its level is going to be raised. It is going to be changed. Yes, you can easily find out that all these measurements. Okay, we can get that. Let's go for that. Yes, if you are going to remember this table, you can easily find out that special units that you have to get this one. Yeah, you can take that. In the previous case, you can get that, just you have that Newton per meter square or dyne per centimeter square. Yes. So you are going to get that Hg, mercury, just it's going to be, yes, you have to get that mm, 760 mm. Its conversion is very clear. You are going to that, you will get that bar, you will get that torr. Just these are all the units to represent the pressure, atmospheric pressure. At the same time, we can go for that force acting on that body. Does it produces the displacement? It's okay. We will confirm it's going to be the work done. At the same time, you will get that work done. It's equal to force into displacement. You have to confirm. This is very clear. So force acting on area, does it gives the pressure? It's very clear. Right. If you are going to act the force in the perpendicular direction, if you are going to take that, this is very easy to solve the problem. If you are going to act that in the perpendicular direction, yes, there is no displacement. At that time, work done is equal to 0. It's very clear. There is no displacement. If you are going to act in this direction, there exists a displacement. Okay, we are going to consider the direction also. That is also very important in the calculation of work done and displacement. Right. Let's go for that special units. Okay, let's have the look into that matter. That is power and work done and time. Rate of doing work is known as that power. Very clear. You have to confirm. Yes. Yeah, you have to take that rate of doing work. work. It's a power. Yes, you have to take this one. This is very important for you to get that understanding. So you will get that power is equal to work by time. You have to estimate that power. Yes, especially we are going to talk about that an electric motor which is used to lift the water from the deep well. Yeah, you have to take that in how much time does it lift the water, amount of water. It can be depending on its working efficiency, work. Yes, then you can estimate the power easily. All right, we would like to go for this one watt. We would like to here. You would like to take that joule. You would like to take that second. Or sometimes you can take that kilowatt, kilojoule by hour. Yeah. Generally, you are going to get that estimation kilowatt hour, kWh. Yes, kilowatt hour. Just we have to get this power consumption, its measurement. Easily you will get that. So you have to take that 10 power 3 for kilowatt. You have to take that 10 power 3 joules for 1 kilojoule. Just it is very easy for you. And if you are going to take that hour to second, just you have to take 3600. Just you have to take that 60 into 60. That is going to be 3600 seconds. So in this way we can do the problems. We can have the conversion and its final result. While you are going to measure that one physical quantity and a one system of units, if you want to express the value in another system of units, just you have to multiply with these parameters and you have to get the conversion also. All right. So easily you can get that. Here you would like to go for the formula that implies work, that is going to be P into T. It's very clear. And sometimes you will get that work done is equal to force into displacement. Easily you will find out that. This is also very useful to calculate that macroscopic phenomena and the displacement of the object. All right. Very clear. Have the look into that matter. You can easily understood that. All right. Okay. In this way, you can solve the problems. Yes. Okay, students. Let's go for that. Another concept. So easily you will measure that. You can take the time is also that one measurement to decide that how it is going to be having the efficiency. Within short period of that time, work is to be more, then you will get that high efficiency, right? Right. Okay, let's go for that. Another one. Special units of length. While you are going to take that special units of the length, you know very well about that macroscopic phenomenon, right? You can take that macroscopic and microscopic phenomenon. Microscopic. Yes, you can take that. Yeah, you have to take that. With our naked eye, we can see that macroscopic phenomenon. Yeah, you have to get that displacement. You will get that distance. Yes. So you can identify that with our naked eye. Yeah. But while you are going to get that microscopic phenomenon, let's have the look. That is, you have taken that, you have been identified that. Yeah, it's very easy for you. So this is the nucleus, just we have to see. Yes, you will get that electron which is going to have that, which is going to be excited. Now you are going to get that this is going to be that first orbit, this is going to be R2. Now easily you can find out that R1 and R2, they are going to be the radius of the first orbit, radius of the second orbit. You have to take that special unit for them. Yeah, it is going to be the very small, it is going to be 10 to the power of minus 10 meter in the order of, yes, you have to get that 0.5 into 10 to the power of minus 10 meter to, you will get that. Yeah, you have to identify that in the range of, yes, it is very small, it is going to be 0.5 into 10 to the power of minus 10 meters to 10 to the power of minus 10 meter. Let us have that some range. So you have to get that displacement, you have to get that electron is going to be, the presence of electron, sometimes it is going to be excited, sometimes it is going to be de-excited to maintain the stability. How it is going to be having that stability? Suppose if you are going to get that one object which is acted upon that force, it is going to be displaced here. Yeah, here F is equal to 0, it is at rest position. Alright, this is very clear, we would like to know about that. If you are going to get that the motion of in a macroscopic object, just you have to get that the macroscopic bodies which are having acted upon that force. So until the force is going to be acted on this body, it is having some motion, very nice. Okay, if you have seen that electron which is acted by the force, all right, from that nucleus it is identified there exists a force acting on this nucleus, very clear. From other atom also, if we are going to get that, so various forces are going to be acted on this one. Okay, it is going to excite and de-excite, right? It will gains whenever it gains energy. In order to maintain the stability, it will loses some energy. Whenever it requires energy, it will gains. Whenever it was going to have that excess energy, it is going to be getting emission, absorption. It will go to higher level and lower level. So in order to maintain that, in order to get that sustainability in this orbit, it's very clear. These are all that. So you have to measure that electron volts. Yes, you have to express in terms of electron volts that energy difference from that one orbit to another orbit. Whenever electron needed energy to excite, it's very simple. It's going to be 1 electron volt. It has been getting that conversion, 1 electron volt is going to be in the joules also. It's very clear. Yes, you can have that look into that matter of this microscopic phenomenon. At the same time, you will go for that nucleus also, you will get that measurement and the nuclear reactions also. Yes, it's very clear. So easily you will identify that energy is the function of the distance which is going to be separated by that. If you are going to talk about that potential energy, it's going to be the function of the separation distance also, size also, it's very clear. If you are going to get that kinetic energy, how it is going to be moving, right? All right, force is also the function of the distance. The force is going to be changing with respect to the R and all. All these parameters are very important, you have to know that. Okay, let's go for that. Yes, very clear, we would like to go for that. Okay, some special units are going to be considered to have that length. micron. 1 micron, if you have taken that 1 micron length, it's going to be 10 to the power of minus 6 meter, right? You know, aerosols, the presence of the dust particles and some small tiny particles which are going to be very small, they are going to be entered into your respiratory system, just they are going to affect. So you are advised to wear the masks which are not going to have that, not allow the foreign bodies which are having very less magnitude, right? You can stop them to have that better life. Just 1 micron, if you are going to avoid that bacteria not to enter into your body, you need to get that. You need to get that virus also. You need to stop the virus and all, right? So 10 power minus 6 meter, it's going to be that 1 micron, all right. Let's have that 1 angstrom unit. It's very clear. The size of atom, while you are going to talk about that size of atom, let's assume this one. It's going to be its atom. Its size means you have to talk about that in the order of 10 to the power of, just you have to get that. Size of atom means you have to represent that radius of atom. Just you have to take in the terms of angstrom units, and you can measure that its volume 4 by 3 pi r cube. So you can take that volume of atom also. It's going to be 4 by 3 into pi into some angstrom whole cube. Easily you will get that x. Instead of that value, we will take that x. That is going to be having the range 0.5 to some 2 or 2.5. You will get that. So whatever, depending on that atom, its size is going to be changed. Whatever. Generally, we would like to go for this one. This is about that calculation of, we would like to represent the size. Okay, right. Let's go for another one. Astronomical unit. It's very clear. The mean distance of the Earth from the Sun, it's going to be identified. So let's have the look into that matter. That is going to be absolutely 1.5 into 10 to the power of 11 meter. It's very clear. You would like to go for this one. So here you can confirm that. Yeah, 10 to the power of 3 meter. It's going to be 1 kilometer. Just you have to take that 1.5 into 10 to the power of 11 meter. That is 1.5 into 10 to the power of 8 into 10 to the power of 3 meter. Let's have that. So that is 1.5 into 10 to the power of 8 kilometer. We have to get that conversion also. In what way does we can represent? Okay, all right. Let's go further. Another one. Yeah. So okay. While you were talking about that light year, so light year is the unit for the distance. Even though if we are going to consider that the distance travelled by the light in a 1 year, so it represents that the distance travelled by the light in 1 year. If you are going to get this value, it's easy to understand that 1.46 into 10 to the power of 15 meters. 1.46 into 10 to the power of 15. Just you have that, you have to get that. Yeah, you have to confirm that light year. You will get that. Yeah, it's very clear. In the range of that 10 to the power of 15 meter, that is 9 point, actual value is going to be, yeah, we have to get that 9.46 into 10 to the power of 15 meter. All right. So 9.46 into 10 to the power of 12 into 10 to the power of 3 meter. So 9.46 into 10 to the power of 12 in kilometer. Yeah, it's going to be 9.5 into 10 to the power of 12 kilometer. It's very clear. You can easily find out that. Okay. Yes, you can guess it. It was approximated as that 1 light year is equal to. Yes. Okay, it's very clear. We would like to go for that 1 mile. It's going to be 1609 meters, approximately 1.6 kilometer. You have taken that 1.6 kilometer. It's very clear. You can get that. So, right. Special units of time. You have to get that solar day. Yeah, easily you will find out that. Let's have the look into that matter. It's the time interval between the two successive returns of sun to the meridian, the time taken by the earth to complete one rotation about its own axis with respect to the sun. So, the average value of the all days of the 1 year is known as mean solar day. Just you have to confirm. Right. Sidereal day, and it's also very clear. You would like to go for the basic definitions and all. You will get that. The time taken by the earth to complete that one rotation about its axis with respect to the fixed star. Just you have to confirm. Okay, it is all about the distance. They have been covered that in a particular, along their path in a particular period. Just you have to take that. The distance covered by that in a particular interval of the time. You have to find out. Yeah, just you have to get that solar year. It's easy, just you have to take that the time taken by that earth to complete that one complete revolution around the sun. So, in its orbit, it's very clear, around 365.24 mean solar days. Just you have to take this one. Easily you will find out that. Right. At the same time, you will get that sidereal year also. Okay. Just have the look into that matter, what the relation that we can go for that solar year and sidereal year. Right. Leap year also, you will have that one extra day. Right. Yes, you can confirm that special units of the time, it's going to be the lunar month, time taken by the moon to complete the one revolution around the earth, it's going to be 27.3 days. Yeah. Just you have to confirm one shake, it's going to be 10 power minus 8 seconds, just you have to take. Special units of mass, small to large, just we have to take that. Please have the look. Yes, one atomic mass unit. We would like to take that reference of the carbon atom C12, that's going to be identified that 1/12 of the mass of the one carbon atom. It's around that 1.6 into 10 to the power of minus 27 kg. Just you have to see that is 1.67 into 10 to the power of minus 27 kg. So, 1/12 of the mass of one carbon atom, you have to get that, that's going to be N. It's a final calculation after getting that Avogadro number, N is going to be, so easily you will get that its value is going to be that 1.6 into 10 to the power of minus 27 kg. Alright, let us go for that slug, 14.59 kg, it's very clear. So, metric ton, 1 metric ton is going to be getting that 1000 kg. Yeah, you have to get that. All these are going to be having that different units, just you have to take that. These are all the basics you would like to know about that. Yeah, while you are going to talk about that pressure, we have discussed about that force acting on that unit area that gives that pressure. Due to presence of the environment, so which you are going to be getting that there exists a pressure, you have to measure that pressure, 1 atmosphere, 760 mm of Hg, 76 cm of Hg also, you will get that, it's very clear. So, easily you will solve this problem by having that conversion. So, it's going to be getting that value. Yeah, 1 bar is equal to 760 mm of Hg. It is easy for you. Now you will get that all the conversions also. Yes, we would like to know about all 1 bar. Yeah, so we would like to go for that Pascal and the representation in torr also, right? So in the coming classes also we would like to accept the problems which are related to the microscopic phenomena. Thank you very much. Have a nice day.